Theory of dynamic interactions. Introduction. We live in a physical world based on the fact that everything rotates, though for the simple observer it seems as something is just moving there in the sky. In reality, we are living in a physical world based on the intrinsic movement on axis of symmetry. The planets rotate on their axis and orbit, as well as their satellites, the planetary systems and galaxies. In the laws of mechanics, there does not exist a mathematical correlation which relates the movements of orbit and rotation. However, the question of the existence of a physical relation between both movements, which has to date not been mathematically shown, can be raised. D'Alembert, in his work The Precession of Equinoxes, published in 1749, was the first to define scientifically the movement of a solid around a fixed point. D'Alembert thought there was a similarity between the behavior of the Earth and a spinning top. Fascinated by the remarkable behavior of rotating objects, man has converted into games and toys many phenomena with intrinsic rotation and has tried to justify its behavior based on the principle of conservation of angular momentum or based on other effects. The behavior of a spinning top is different from that of a gyroscope because its revolving axis is resting directly on an external surface which can produce a gliding movement. The axis of a gyroscope, on the other hand, is always leaning on a rolling point of the apparatus itself, as no gliding can be generated. In the case of a rough surface, the spinning top, as well as the gyroscope, will keep its contact point fixed. If we clean and apply a thin layer of oil on a stable table, we will observe that the spinning top will trace a precession path, a path which is apparently circular. If the surface of support allows the gliding, the spinning top will initiate a circular movement, providing a certain inclination to its axis. This revolving movement around a circle and its axis inclined is a demonstration of the interaction which is generated between the torque of weight and its contact point and the intrinsic angular momentum of the spinning top. It is a precession movement which is kept as long as the spinning top disposes of an angular momentum. From a physical point of view, this experiment allowed us to suppose that the angular momentae of rotating objects are not added up algebraically or vectorially in one single final momentum, as the composition of momentae is not a general law. It was thus necessary to generalize this supposition to other experiments. The following figure shows the angular momentum of a spinning top subject to the action of its own wave and its variation. We can propose that including in the supposition of the spinning top without the gliding in its contact point, the initial angular momentum L and its variation increase L are not added.